Let's explore matrix addition and determine whether the addition of matrices is commutative. The first really important thing to know about adding matrices is that you can only add matrices if their dimensions are exactly the same. What I mean by dimensions is I need to look at the number of rows in the matrix and the number of columns in the matrix. So for example, matrix A has 2 rows and 1, 2, 3 columns. So we call that a 2 by 3 matrix. It's always rows first and then columns. I remember that like RC Cola. Let's take a look at matrix B, and matrix B also has 2 rows, and it also has 1, 2, 3 columns. So matrix B is also a 2 by 3 matrix. Are we allowed to add a 2 by 3 matrix and a 2 by 3 matrix? Well, their dimensions are exactly the same, so yes, we are allowed to add them together. If we were to try to add a 2 by 3 matrix with a 2 by 2 matrix, that we wouldn't be allowed to do. But as long as the dimensions are exactly the same, we can add the matrices. You'll see later that the addition of matrices is very straightforward, but that the multiplication of matrices is pretty complex. So if I'm adding matrix A plus matrix B, I'm going to write out matrix A plus matrix B. I'm being very specific to make sure that I'm following the order that the problem asked me to do, A plus B. In the next example, we'll be adding matrix B plus A to see if the results are the same. So in order to add matrices together, the process is pretty straightforward. All that I do is I add up the corresponding entries. So I'm going to take the entry in the first row, first column of matrix A and add it to the entry in the first row and first column of matrix B. So all I'm doing is 8 plus 6, which is 14. That gives me the entry in the first row and first column of my result matrix. Next, I'm going to add the entry in the first row, second column of matrix A with the entry in the first row, second column of matrix B. -1 plus 2 is 1. And then to finish out the row, I'm going to do exactly the same thing. The entry in the first row, third column of matrix A and the first row, third column of matrix B. 4 plus 0 is 4. To do the second row, I'm going to repeat the exact same process. So I'm going to be adding 3 plus 9, because those are both the entries in the second row, first column of each matrix, and I get 12. And then 0 plus 4 gives me 4, and 2 plus -1 gives me 1. So this 2 by 3 matrix that I get is the result of adding matrix A with matrix B. Next, we're going to add these in the reverse order to determine whether matrix addition is commutative. So next I'm going to add matrix B plus matrix A. I'm going to do this using the exact same process that we did when we were adding matrix A plus B. I'm going to go to the first row, first column of matrix B, which is 6, plus the first row, first column of matrix A, which is 8. 6 plus 8 is 14. Next, I have first row, second column of B, plus first row, second column of A. 2 plus -1 is 1. First row, third column of B, plus first row, third column of A. And then I move on to the second row. Second row, first column of B, plus second row, first column of A. Second row, second column of B, second row, second column of A. And finally, second row, third column of B, plus second row, third column of A. If I take a look at the results that I get, I see that they are exactly the same. So, in conclusion, we can say that yes, matrix addition is commutative. So it doesn't matter whether we're adding matrix A plus matrix B or matrix B plus matrix A. We get the exact same result. Just remember, whenever you're adding matrices, make sure that your dimensions are the same. And dimensions are named rows by columns.